Hello, my friends. Welcome back to another fun practical Python project. In today's video, I'm going to show you how to take an image and convert it into sketch, right? And then we're going to use the same technique to do some little, fun video processing. We're going to take a video and convert that into cartoon if you want, or in a sketched format video kind of thing. Um, and for today's video, I'm going to use mostly the CV2 library or OpenCV, the computer vision library of Python, which allows us to easily do some light image and video processing. So let's get started. I'm just going to go import CV2. If you don't have it installed, as always, just you can Google how to do that. But usually pip install OpenCV would do the job for you. Uh, anyway, let's get started. I want to define a function to do this for me, and I'm going to call that image to sketch. The input to this function would obviously be the original image. So original image, we're going to get that and return and sketch the image, right? What's the first step? The first step is to convert the input image into grayscale. Okay. So I'm just going to go image gray, just any variable name that you want. We're going to use the CV2 library, CV the color, and so we're going to get the original image as the input to this function, and CV2 dot color. I think it was BGR to gray. Yeah. So yeah, the CV2 library mostly used BGR, but you might be more familiar with RGB. It's the same thing, but the order is just different. This is blue, green, and red. Anyway, we have the grayscale image here now, and you can go crazy. You can just like, I don't know, like do whatever you need to do here. You can like at the end of each step, you can see the result and be like, okay, print the result for me, or like show it. And you can use matplotlib or any other thing for that purpose. So that's the first step. The second step is inverting the image, right? And inverting is basically just taking any color and turning it into the exact opposite. So like a black goes to white, white goes to black, and so on and so forth, right? This is important because if you do this in the image processing application, you're gonna get more details in your picture. Anyway, let's do that. I'm just gonna call that image invert. That equals CV2 that B was not, because it's inverting it, and the input would be image gray. So we get the output of the previous step and use it as the input to this step. Another step that people usually do, it's optional, but it's a good practice to do, is to add some Gaussian noise to blur things. It makes the photo look smooth, right? Well, let's see how it goes. I'm just going to show you, but you can obviously skip this step if you wanted to and compare the result, like plot it for yourself, see how different it looks. So image smooth, and I call that equals CV2 dot Gaussian blur. Here the input would be the output of the previous step, and the filter size that we're gonna use, I don't know, like you can go 21. That's like a normal one, very common one. And it's a Gaussian distribution. You have to provide the sigma. So I'm just going to go sigma x equals 0, sigma y equals 0 as well. And then we have to invert it back, right? So I'm just going to go move invert equals, just going to get that guy from here and use it here. But the input now would be this guy. Looks good, right? And now that we have that, the final step, let's just like separate these steps. The final step would be converting into sketch, right? So I'm just gonna go image sketch equals cv2 dot divide, and I'm gonna get this guy in here, and I'm gonna get this guy in here. You can look into the documentation to see how exactly this function work. I don't really want to get into the details. Just want to show you quickly how we can do that. And the scale is 256, and return image sketch. That's good. And let's see if it works now. We have to call this function. So let's make her main if underscore underscore name underscore underscore equals, and then inside here that's main. Then so I have a sample image, this guy randomly picked it from internet, the photo of this lady, and we want to do that. Let's see how it looks. So I'm just gonna read the image first, right? So I'm just gonna go image equals cv2 dot im read. That's image read, and the name of it was test underscore image dot jpeg. Right now that I have that, I can actually use the function, like call it here, that be, let's just bring everything from here. So this equals that, and this is the image. I read the image and I'm using the image as an input to this function, and once it's done, I just want to save it to a file, right? So cv2 dot image, right? As you can guess, if we have read, then we have write, right? And I'm just gonna give it a name. I don't know, sketched image, maybe. That PNG, for example, and then you wanna write this guy. So it gave it a name and the content of that image to write. And if I do this now, it's done. If I look here, I have sketched image. Let's take a look at the original one for now. This is what the original one looked like. And now after sketching, it's a beautiful sketch. You can use that, use a photo of yourself and make it look like this and put it on your wall. That would look really nice. And that would be your code as well. So it's a piece of art and also done by you, which is really amazing. For someone like me who doesn't know how to sketch, that's like the way I would go. Okay, so this is good. This is the first step. And now we want to use what we learned here to do some video processing, as I promised you. So I'm going to define another function. And basically what we want to do is to read a video file, divide it into different frames, right? And do the same operation like image to sketch function on each of the frames, and then put all the frames back together and make a video. Cool. Hopefully that makes sense. So I'm gonna make a function and call that video to frame. And obviously we need like a original video again. And then once we have the original video, this is where we have to use the CV2 library again. So I'm just going to create an object, call it video capture, right? That equals CV2 dot video capture of the original video. Okay, it gets the video and it knows that what we're about to do with that. And the cool thing about it is that like I can go frame per second. We want to get some information from our video, right? And so I'm going to use that dot get cv2 dot cap prop Yeah, cap prop underscore FPS, I think. Yeah, here. So that gives me the frame per second of the video. I need that for when I want to put the frames back together. So we have that, and we can go success and image equals vidcap dot vid. So what this does basically is that it starts reading frames of the video. This function, right? Starts reading of the video frames. If the frame is there, like it's not the end of the video, it returns a Boolean value, success, and that frame. And I'm just saving that frame into like a variable named image. And I'm just gonna use a variable and name it 0. And you'll see what I need that. And I'm gonna go while success, right? Success is true now because it's a video. We have at least, excuse me, we at least have one frame in it. So in the beginning, it's 1, and it reads 1 frame at a time. So this condition is true. And then we go here, and then we can say cv2 dot I am right, and we want to get all the frames and save them somewhere, right? So let's create a directory here, call it all frames. All the frames go in that directory. So we want to write into that directory. So I'm just going to go all frames, and the name of the frame that we want to save in there would be, I don't know, frame. And now we have to separate them somehow. That's why I have the count variable here. So I'm going to go %d, right, dot jpg, and then that, and then that would be %count, right? So let's see what I'm doing here. So basically what's happening here is that it's saying while success is true, take that frame, and the frame is obviously image if we want to save the original image, but we want to do this. I'm going to put this in here of image. So for each frame, I'm going to get that frame, call the image to sketch function that we wrote, right, on that frame. Now we have the sketched frame, and then I'm going to save it here, right, in this directory named as frame %d. Previously, what we saw was when I was printing something, I would go print f and then something, and then a variable name would be something here, right? This is another way of doing it. I'm just gonna, we'll call it frame %d, and by %d, I mean like use this value here. So for the first frame, it's gonna be frame 0. For the, I don't know, frame 20, it's gonna be frame 20, right? This is how I'm just like automatically make it use different names for that. And the names are gonna be in order, right? That's the point here. And then obviously we read the first frame, and I'm gonna do the same thing for all the frames here, right? Success image is video captured read, and these loops continues until we get to the end of the video. And then we obviously have to go count plus equal 1. So that's good. So this function is supposed to get all the frames from video and save them in the directory called all frames that we created here. It's empty because we haven't run this function yet. That's good. Okay, to the next step. What would be the next step? I want to define another function here, and I want to call that get image size, right? And gonna get image name. I'm gonna give it a name of a file, and I want it to open the image for me and returns the image size for me, right? So I'm just gonna go image equals image. I'm using a different library here. See, you could obviously do that using the CV2 function, but I'm trying to show you as many functions as possible, right? So I'm just gonna go in addition to CV2, I'm just gonna go import from PIL, which is the pillow. If you haven't installed it, go ahead and install that. Import image, right? And while we're here, we need quite a few more. I'm just gonna go import numpy as np, import os. Oh, let's do this from import from os, import walk. Okay, that's good. Import says maybe we don't need them all, but because we are trying to read all the frames that we have saved before in this all frames directory, we're gonna need some OS and system libraries probably. So I'm just gonna add them here, and if we didn't need them, then it's all good. We can get rid of them. We can go import os dot path as OS path. I think we should be good. I will go if it was complaining about some missing libraries, we can always come back and add them here. Let's close this one, close this one. Okay, so image is image that we called from the pillow library, and we're gonna read that one. So image that open, what are we opening? Obviously the image name, so it gives the path to the image and it opens the image for us, and then we're gonna return image dot size 0 and image dot size 1. Cool. So this function returns the image size for me. I need depth because when I want to make a video, I need to tell it what the frame sizes are, right? That's why I have this function. Now let the fun begin. So I'm just going to define a function here, and I'm going to go video to sketch video, I guess. I don't know. You can come up with a better name. This is not honestly the best name. I give it a variable o video. That's the name of the video that I want to save later. And let's start. So the first thing we need to do here is to call this function, right? Call this function, and that's cool. If we call this function, it gets the original video, and what's gonna happen is that it's gonna frame it for us and write all the frames in that all frame directory. So do this, and this function needs the original video. The original video is something that I have here, test video. Again, I just found it online, this video. It's about a client doing something. That's what the description of the video was like. So this is what the video looks like basically, right? Anyway, so let's use that test video dot mp. It's an mp4 video, so we're gonna do that. And now I want to read all the frames that we previously saved. So I'm just gonna go image files, right? That's an empty array. Okay, for not the way I wanted to do it, that's an empty array. And now I can go for R, D, and F in walk, and just give it the path, all frames. So in that directory, what I want to do is that for file in F, so that returns all the files in F variable, right? And I'm going to say for each file in the f variable, then image width and image height equal, let's call this function that we use here, and OS path, the one that we used in the libraries, and the join R in file. Okay, so this is gonna, so this check-in here is just to tell Python that, okay, go to that path, read all the files, open them as images, and return width and heights. That maybe we don't even need to do that in a for loop because like they all are the same size. So I can like take it out of for loop, but for the sake of this program, let's just keep it here. And now that we read that, we can just append it to this list in here. This that append OSP dot join R in file, right? And I want to add the path for like the file name for each image here, so it contains, you know, all the images. So it's going to be all frames, frame 0, frame 1, 2, 3, and so on and so forth. And then because I want to make sure that I read the frames in the sequential format and in order, I'm just going to go image files dot sort. So it sorts them from frame 0 to frame 140. Okay, so far so good. Now I have read all the frames and saved them in this list in here. The next step would be to actually write the video. So I'm just gonna create a variable, call it frame shape. This frame shape is simply needs t, right? It's the image width and image height, right? And now I need to define a codec for my video. I want to create a video. I need to define a codec. How they usually do that is that they go for C. No, I meant to the right. That equals CV2 dot. I think video writer. That's cool. Video writer underscore for CC, I guess. And Yigo star. We want it to be MP4, so I'm just gonna go MJPG, I guess. I guess that's what it was. If it was complaining, we'll come back and fix that. Don't worry about it. And then the video that I want to create is obviously CV2 dot video writer, and the name of the video that I want to create. It's this guy. The codec of the video. It's this one that I created here. It's basically say that I want to like use this codec for my video. The frame per second. So the frame per second was the output of this function here. Right? Oh, here, let's just return FPS because we have FPS, but we never used it here actually. So here, when I call video to frames, I'm gonna go frame per second equals that, and I'm gonna use frame per second here, and the frame shape. This creates the video object for us. And so finally, the last thing they need to do is to read all the frames and put them all together. So for frame number in range of length of image files, right? I'm just like iterating through all of them. I'm gonna go f path, file path is equal image files frame number, right? That gives in the file path, which in this case would be all frames slash frame 0, frame 1, frame 2, so on and so forth. So we have the file path, and I'm gonna go, the frame that I want is cv2 dot imread, right, file path. So read that image for me, and now that you read it, video, this object that we created here, right, video dot write frame, write that frame into the video, right? And once it's done, we have to go video dot release, so it releases the video. This looks okay now, and let's see if we can actually use that now. So if I call this function, let's bring it down here, and I want to call it, I don't know, like sketch video dot mp4. So what's going to happen, let's go over that one more time. If I call this function, it's going to call this function inside. It's going to get all the frames and return the frame per second. And then we're going to get all the file names, like the frame names that we created. And here we're just going to read them all and put them back together. Should be good. Let's run this now, see if it actually works. If I run this, it's doing a thing. Because it's you have to read all the frames separately and do the operation. It may or may not take a while depending on the, like, how strong of a system you have. But let's see. I forgot to run it. Okay, it's doing a thing. Just gonna wait until it's done. Okay, so you see it's still going something, but we can see some warning here. It says that thing is not supported with codec ID 7, that, and the fallback to use MP4V. I don't think these are important warnings. But let's see what happens. It should be done hopefully soon. While it's doing its thing, which by the way is done now, you can play with this frame per second to make your video fast and slow. It's going to be like slow mode video or like a fast paced video. You can just keep playing with this, with these parameters to see how it looks. Looks like it did it. It created the video for me. I can see the sketched video MP4 here. Let's run it and see if it actually works. It's here. And yep, so it did it actually. So you can see that it converted our video to like sketch format, which is really cool. So it worked. Awesome, great. Well, as always, thank you for watching me, and don't forget to subscribe so you won't miss our next videos. And you have a good one. Bye bye. Take care.